So with SYAHI, we already have a podcast series. We are nowadays we are discussing the rethinking urban environment. The last podcast by Professor with Professor Kumar Gupta was so fantastic, and then we were like we were in have a workshop on Python where we attract 400 plus early career researchers around the globe. And in this workshop, we received around 120 responses, overall 120 responses, and 50%, 51% from India and the rest from the world. And most of the participants were a little more aware about the HYDRUS, but the large participants are unknown to HYDRUS. That's why we designed the entire workshop to have first the basic knowledge, basic understandings, and then a basic information or hand-on training on HYDRUS 1D. And it was the first day. And then in second day, we were more complex with the 2D, HYDRUS 2D and HYDRUS 3D and the HYDRUS add-on modules. And SYAHI is thankful to Professor Sumenic for his time during vacation. And yeah, it was a nice session yesterday. And today there is a 1 hour session, and we are supposed to deal with these problems by participant. So this is all about our workshop, and yeah, you know all how to install and the pages of easy progress to deal with these example files. And yes, everything is now known to you. So I'm going to escape here and I'm going to reshare my screen to show you today's problem. Okay, so if you open your example file, which I already circulated among all of you, we have a drainage related file where we have to simulate the drainage from one-dimensional 35 centimeter of soil, where one can apply the flux to recharge the groundwater or recharge the subsurface or root zone. So we are solving the inverse solutions where we do have like recharge rate. Since we have the flux, applied flux, or the depth of the recharge, and based on the depth of the recharge and the domain information, we will start calculating the soil hydraulic properties. So let me connect my another. So then, to start with this problem, you need to start your 1D HYDRUS 1D, and then you have to open your open this file. So start with this HYDRUS 1D and try to open this file. So I'm not going to open the whatever we have already done here. So I'm going to start by as a new project. Okay. So as you recall the yesterday's talk, we have to put some name here. For example, SYAHI 1 and description. Then so we are going to yeah, so this is this interface will appear after when you create the project file.
Sir, the screen is not shared.
Oh yes, I have to reshare the screen. Okay, I don't know why, but entire screen is not able to share the entire screen. Okay, so you can see now the new pre-processing tab with HYDRUS. Is it visible to you?
Yes, yes.
Yes, so after project file creations, you will, so these tab will open, pre-processing tab will open, and then we have to start. As we select the drainage flow, so we have option for water flow, solute transport, heat transport, root water uptake, and CO2, and the inverse solution. As I mentioned, that we do have like the drainage. Let me show you again the what we do have as a data, and then we'll you can see here the volume of water as a recharge was measured with the time step. So we are going to simulate these volume of water, recharge water through the domain, and we are and the volume recharge is known to us, and the hydraulic properties are known to us about the fitting parameter alpha and the theta s. Theta r is porosity, so theta r is theta s is porosity, so theta s is known, and theta r is not unknown to known to us. So we will simulate the theta r and alpha and the other hydraulic conductivity parameters based on the whatever we do have as a recharge data. And these recharge data can be like can be estimated in any laboratory experiments or any field experiments. It's quite easy. It's nothing. It's simply the recharge with versus time. So we do have the volume of water recharging every with the time steps. So we have like data set for example 2136 second. So, and we have a cumulative recharge data set. So we will solve the problem using this data set. So then we have to then we have to select the water flow as well as the inverse solution. If you remember my first day talk, if you have like output data, and then if you don't know about the soil hydraulic property, then you have to select the inverse solution to simulate the inversely, the parameters inversely. And we are not interested now for the solute transport, heat transport, root water uptake, and CO2 transport. So we will uncheck these box, and then we'll go next. Okay, in next they are asking for what type of estimate inverse solution we are looking for. Then we are looking for soil hydraulic property, that is theta r and alpha and the ks. So we have to check this soil hydraulic parameters. And then the next, if you remember the first day demonstration, they will ask you about the number of soil material. And in our case, the number of soil material is 1. So we'll put in this box is 1. And number of soil mass, layers of mass balance will, as we do have the single layer, so we will apply 1. and the our axis or our domain is vertical, so we'll use 1. Otherwise, if it is like horizontal, then we'll use 0. So in this case 1, and the depth of the water soil profile is 35 centimeter in top layer, so we have to put the 35 centimeter, and we have like a millimeter, centimeter, or meter tab to select our domain length, and then we have to select next. In next tab, as if you remember again, we do have tab for the time unit. Let me unmute someone. I don't know.
Sir?
Yes. Do you have any question? Hello.
Hello?
Yes, any question?
Yes.
Yeah, please feel free to ask me. Yeah.
Okay. How many depths of soil profile can HYDRUS detect? For example, now you put 35 centimeter.
Yes.
What is the maximum depth of that?
Maximum depth?
Yeah. Yes.
It should be like 3,500. Depends on your data set, whatever you have data set.
Okay.
If you remember the litholog, in last presentation, so if you have like soil profile depth till like 35,000 meter or in kilometer, you can simulate in the kilometer as well. Depends on the HYDRUS 1D or 2D. In 2D, we do have facility for the like kilometer or larger scale simulation, but in HYDRUS 1D, we have like in meter. So even in meter, you can simulate the large litholog. So generally, we prefer, see, the HYDRUS is all about the variably saturated simulation, Richard equation simulation. So generally, we simulate the soil profile from the top to the water table in this with this software. So generally, these soil profiles are in either in kilometer or in meter. So one can simulate very easily whatever they do have data. In our case, in this case, the soil profile or the data, whatever we have, is related to 35 centimeter of the depth of the soil.
Okay,
and then,
thank you.
Yeah, you are welcome. And as you remember the Excel file, we have the data for around 2100 around 36 100 second. Okay, and then we don't have a data for precipitation and like a time variably boundary condition, so we will uncheck this one. If you have like a precipitation or meteorological data, then you have to select the this box, and then you have to fill the how many records or how many precipitation data you have. So then you have to select here, and it will provide you another window to provide these data set, but we don't have the time variably boundary condition here, so we will uncheck this one here. If you so 0 initial time step, we have to provide as 0 second, because we are going to start the simulation from 0 second to 300 second, and then we have to take care of these initial time step and the maximum or minimum or maximum time steps. But these are like very by default selections, so sometimes you no need to worry about. In this case, I have selected the okay, and And then the print output, that is all about the data. Print output data related to the data. It depends on your choice how many times you would like to have your data printing. For example, I would like to print my data in 20 steps, so 20 different time steps. So it will then print in 20 different time steps like this one. Okay. And then they are asking for the number of iterations. So in case of number of iteration, then again we have to take care we have to try to iterate the numerical domain for like maximum time. In this case, I'm selecting like 50 time iteration, or one can select 100 time iteration, depends on numerical capacity, and it will take little more larger time if you select the largest iteration number. And then we have to minimize this water content tolerance. So let's minimize the and then because our domain is like a single material domain, so I have to select the single porosity model. But within the single porosity model, if you would like to simulate the dual porosity or dual permeability, you are allowed to do that, because we do have these numerical equations to solve the dual porosity as well. And even in single porosity, we do have 2-3 options to simulate. But in this case, I'm just simulating the VCM equation. So I have to select the VCM. Yes, this is new, and you have to take care of these parameters in an inverse solution for material 1. If you have like 3-4 material, then you have to take care for all these material. See, here they are looking for initial estimate. Initial estimate is estimate generally we perform in our laboratory. For example, in this case, we do have 0.15 means very dry soil, theta r, and the porosity is very high, like 0.92, and the alpha values are 0.47, and the n value is 5.6. And one can explore these values even in literature. So every sand or soil, or for every material, we do have a range of alpha n or ks. So one can refer these maximum or minimum value as well from the literature. So you need to provide the maximum or minimum range as well. But this is nothing. This is just a number for in case of inverse solution, because in inverse solution we are going to ask this model to provide these value accurately with us by matching our the drainage or recharge pattern. So let me provide some value here. Okay. So 8. Okay. So, and if you are interested to fit your QR data set, you have to check this fitted. Okay, so then you have to check this 2-3 value, whatever you want to have like as an inverse solution, because the QS, that is porosity, is known to me, so I'm not going to fit this data set. Okay, and in generally KS is also known by laboratory investigation, so generally people prefer to match the KS and to explore the accurate value of theta r or alpha n. Okay, So let's provide the boundary condition. So my upper boundary condition is the constant flux, because we are going to provide them value, the constant water supply value. But the bottom boundary condition, we don't have the flux, so we will select the constant pressure head. And the initial condition in our of our domain in pressure head, because we don't know about the water content, so we have to provide the pressure head as a initial condition. And we also need to provide the data set for the same. And now you can see the upper boundary flux, and for upper boundary flux, this is constant boundary flux. Oh, so we will provide the entire data set here. We will explain. Now they are asking for our upper boundary data set. So we have to add our upper boundary data set. So now I'm going to stop here, and I'm going to start whatever I have already done. This is because we have to either add every line. That means around 2000 lines. So no, 81 line from the Excel. So I'm not going to do from here. I'm going to start the example file again. This is what. Okay, so we have to just copy paste the X and Y value. X is time and Y is your depth of water in different for 81 time step.
Sir?
Yes.
Which data one? We downloaded the data, the example data files. But which one you are selecting now?
Oh, it's new. The drainage, this drainage example is new. I have to share with you. Okay. So first you have to concentrate on a screen, and then I will put in the file again.
Okay. Okay.
So see here, I have done nothing. I have just copied the data from the Excel. If you remember this Excel. So in Excel, I have the different time steps and data of around 81 data sets. So I have just copied these data set from Excel and this data set in this tab. So this is what you need to do to provide an input data set. And for these work, one can write the Matlab code. And in Matlab code, if you have like thousands of recharge data set, then the Matlab code will take care of these input files. And yeah, so you don't need to provide everything every time the add line 81 times you have to add line, or you have to delete line, you have to check the data set no, you have to create Excel file, and then Matlab will take care of all these input. But in case of sorry, do you want to run profile? Yes. Okay. In case of in case of this maximum and minimum value, you have to be careful with your the Excel file or source file, because sometimes if Matlab take the direct data set, you cannot you will be not able to modify this manually in the HYDRUS. Then you have to provide maximum value 1, minimum value 1, maximum value 2, minimum value 2, or maximum value 2 to n number of time. For example, if you are searching or if you are optimizing these values using global search optimization, then there may be 30,000 data sets or 30,000 different pattern of QR, QS, alpha, n, or theta s. For example, in my case, it's more than 30,000 for one example. So in that case, I have to assign the Matlab code that they have to take care of each maximum or each minimum in this HYDRUS. So this is very simple. This is just a one point we are providing the data, but one can provide thousands of minimum or maximum pattern or initial pattern, depends on the global search or optimization pattern, whatever the optimization tool you are using. Okay, and also you have to write a code for line. If there is like a need for another line, then the MATLAB will add the line or delete the line from this input, data input, and then that's all. We have to now like start the let me say it again, because this is new tab. Okay, so this is all about the input, and now we have to take care of our the numerical domain, that is one-dimensional domain. See, first we will see the discretization. So these nodes are discretized in 35 centimeter, and material are distributed, because in this case we do have only one material. So the material is simply one material here, and one can edit like material 2, material 3, material 4, depends on their material. Okay, when you complete this one, they will ask, okay, which type of material you want to assign this domain. And in our case, there is only one material, so we have to assign one. If there are like 1, 2, 3, 4, 5, 6 material, then we have to assign the number of material, which material we are referring at which location of the numerical domain. And number means you have to take care that if you are providing like the alpha or theta value or theta s value, whatever the number, material number in that tab will refer here. So you have to take care of the material distribution then. If large means you have many more material distribution, and then we have to take care of the initial conditions. So in initial conditions we have like one material. So yeah, so it is already in initial pressure head condition, you can see here. Okay, and then we have to provide some observation node. In this case, I'm going to provide 3 observation nodes at different locations to know the hydraulic property and the discharge data sets. Okay, that's all. And then that's all. Yeah. Oh, sorry. And then when you minimize or just cross this profile, they will ask, do you want to run HYDRUS 1D application? And you have to say, yes, I want to run. And after when you allow them to run, and they will open another tab. They will calculate or see this tab. So they have already calculated this problem within 0.59 seconds. So that the fantastic things we have to like recognize, and then you have to okay. Oh my God, every time I have to share the screen. Okay, then there is a new tab that is post participants. Okay, so yeah, post processing. And in post processing, as we do have like observation points, so we can see the pressure heads with different observation points, water content with the different observation points. You can see the theta. We already simulated the theta in this case at different observation points. So on the top, we do have like a saturated condition, but in bottom, we do have like these type of soil moisture curve. And mainly in this case, our objective was to simulate the water flux, water flux means recharge. So let me show you the water flux over here. So cumulative water flux. See this. See the accuracy of the simulation. These dot lines are like numeric. Sorry, these dot line are the input data what we have provided with this HYDRUS, and these line solid line is simulated by the HYDRUS. So you can see at the end of the 400 second, you have very fine or good match. And initially, when the water start drainage with this soil profile, the match is so beautiful. But after 50 second and till the 100 second, there is like some error with our data set, observed data set, and the numerical model. And this is nothing. This is just due to the hydraulic parameter which we have selected, the range of hydraulic parameter which we have selected. For example, see the porosity. It is 0.98. It's so high. So let's reduce the porosity by 84 or 87. Let's say C 87. Okay, and I'm going to rerun again the model, and we'll see how the curve is changing. What is the see the difference. So with these porosity changes, we have huge difference in the water flow. So that means we have to take care of the porosity, and whatever the porosity is observed, we have to provide, and we have to play with the other parameter. And for the other parameter, for example, let's and we have to think about the other parameter like theta r or theta alpha or n. So in this case, let's 35. Yeah, theta r. Let's increase the theta r condition, and then we'll see the match. Okay, so theta r is also not working well with our match. Then we have to reduce the theta r with the whatever we have find in our laboratory, and let's say n. Let's play with n, because n and alpha is fitting parameter. So we have to work more on n and alpha. And these are like not good to simulate using manual hands. So you have the time, you have to see the pattern is much better than the previous one. Only we have to now either increase the theta r or theta s, and then it will match very well. So for these type of changes, you not need to work manually every time. You have to write the Matlab code, and it will work very well. Okay, so I'm going to increase this so that we can have the let's assume this is my best fit with the laboratory or with whatever in laboratory and whatever in simulation. So this is not our objective to match the curve. After matching the curve, we are going to ask the model, we are not interested in your water flow, just provide me theta, whatever the theta r or alpha or n value or ks value, let's say ks value, because we are simulating this problem inversely, and ask them to recalculate. Now it will take little time, and because okay. So in inverse solution, we have everything here. See, soil hydraulic parameters, what we have provided to them, parameter estimated as the initial conditions. See these, the iterations and their initial conditions, and their correlation matrix. If the correlation matrix is like minus 0.9 or between 0.9 to minus 0.9, it's okay to accept, but we have to keep the correlation matrix very close, and see these are the parameters simulated by the HYDRUS, which is like as a universal inverse problem. So you can see here, and the root mean root mean squared value is like 0.095, and the error is also here. So you can see the error is so low, 0.002, around 0.002 root mean square weightage error. And thereafter you have time, observed data, fitted data, and the residual data. Residual means the air, the data, the water which is there in the domain, but not we are not able to like calculate these water as an error. These residual are error. So one can copy these data set, fitted data set, and observed data set to match their curve, and then the water content and the pressure and water content to provide like soil moisture curve and the drainage curve and the different soil hydraulic parameter like WRC means theta R, alpha, and the saturated hydraulic conductivity. So this is all about the inverse simulation and HYDRUS. Yeah, a simple example in HYDRUS. So if you have any question, please feel free to ask me. And yeah, and I'm trying to connect my another laptop so that I can demonstrate the Matlab code and how to handle the HYDRUS using the Matlab code. This is what we have in a one example file, but in general, we have like thousands of data set to run these Matlab code. So yeah. Okay, now stop. Yeah. Yeah. There is one question. Hi, Pankaj, are you going to show how to integrate HYDRUS and ModFlow today? I think Professor Jirka already covered these HYDRUS and ModFlow integration yesterday. If you miss this session, we will provide you the recording, yeah, and then you have to take care of these stuff. So he already mentioned the integration of HYDRUS and ModFlow. If you have any question related to today's example file or example simulation, please let me know, and we will discuss more about this example, because we have to like we have to very clear with our simulation or the error and whatever the parameters we are observing or seeing. And you also have the mass balance to calculate your own error soil hydraulic property. Now it will not provide you the figures because we have to uncheck here remember, uh, if you are checked with this data set, they will not, HYDRUS will not generally provide you these accurate graphs. So then you have to rerun for the graphs. And when you rerun the graphs, they will provide you the accurate, all the graphs you can see in this bottom boundary, bottom cumulative bottom flux. And one can like work to match these error as well, error between the 50-second to 100-second, and by like optimizing the alpha and the maximum or minimum value of alpha. And this is why we refer like global search optimization or other optimization tool to match the, but in case of like cumulative, because this is cumulative water depth, so you can see after 400 or 350 seconds you have an accurate match, so nothing to worry about. Whatever the recharge is there, so your numerical domain is simulating the overall recharge very well. So whatever we have a reverse simulation data set in reverse simulation is so accurate, so nothing to like worry about, but one can improve their results using the global search optimization or other optimization tool. Okay, so I have to stop. What does position 2 mean? Is it node 2, sir? Yes. When we provide like observation point 2 or 3 observation points, the position 2, 1, 3, that means the different observation point. And in case you have like multiple, then you have to highlight, okay, this is my observation point 1, observation point 2, like that. And based on the observation point, you can also have a like different type of soil property or theta, or see the theta. So this is for one observation point, this is for observation point 2, and this is for observation point 3, and depends on where these observation points are located. So one can like figure out where these observation points are located in with this domain. Even we can provide the nomenclature for their nodes, observation nodes. I think to be here. Okay, this is all about the first session. Sorry, first example. Okay. So I assume most of you now very familiar with this HYDRUS example file. And allow me, if you have any question, ask me. Otherwise, allow me to start the Matlab with my another laptop. But I'm not sure, my whole laptop is so slow, so it will take a little. Sorry, if I start my Matlab and code with other laptop, it will take time, at least 10 to 15 minutes. So nothing to worry about. See, with basic progress, we do have a tutorial how to run the HYDRUS using the Matlab. So I would like to request you all to just visit this website, and the email ID is also provided by your originator. If you have any question, you may ask them. So, okay, so see, you only need to incorporate this file. So they have like file with the PC progress. Let me show you. Address 1D and tutorials. You see there, point 10, running the computational modules of HYDRUS 1D from Matlab. Is it visible to all of you?
Yes, yes.
Yeah, so they do have like example file. You have to download example file. Okay, so you can see in this example file. So they do have like Matlab code as well. So you have to export this Matlab code to your Matlab programming, and then you have to start working or modification, little bit modification with the code. So okay, so for example, you have to take care of unit and days, total number of simulations, profile. You have to provide with your code every within the time, and soil properties for the different soil. You have to either provide using the HYDRUS dataset from the HYDRUS tab, or you have to provide your own Excel file as a source. And in that case, you need to select your source file. And then the boundary conditions, you have to define the boundary conditions and initial conditions. So in generally for the boundary conditions, you need to provide as a flux as a different Excel file or source file. For example, in my case, we do have another type, we do have a separate Excel file to export these boundary condition in our graphical user interface. And then you can see here these codes you can modify these code in Matlab, yeah, to plot the water retention curve, to generate the water retention curve, and to initialize these file. And you always remember to like take care of your file directions and the directories, and this is what we need to take care in the. And for the creation directory or input, they have already written something, so you need to modify these as per your interest, and then you have to run the HYDRUS. So this is nothing, this is just a one-page code one can write in Matlab. So nothing like very complex code like that. Only you need to write direction code. So okay, so Matlab, you have to open my HYDRUS, you have to export all the input file, and then you have to design the project, and then you have to run. And for the output file, you may write the code. Okay, so you have to extract the output file as well in the Excel or in the as a plot. So it depends on your interest. Okay, so yes, so this is all about the today's session. Unfortunately, there was only one input from one gentleman, so I'm not able to explore demonstrate more data with you. So, but if you have any problem with HYDRUS 1D, 2D, 3D, just text us with SYAHI member, and we will explore. We have expertise in this software and soil water pollution modeling. So we will try to explore the issues, especially error. If you receiving error for the general question, generally everything is available with the forum, as Professor Jirka Sumanik mentioned. But if you have any issue with the error, sometimes uh, people are working to reduce the error from 10% to 1%, and it take a lot of time. So please feel free to text us, and in next 1 or 2 months, we are thinking, SYAHI is thinking to organize another workshop on integration of HYDRUS with these optimizations tool. See, these are the physical based techniques. So you have a byproduct, or that byproduct is data. For example, matching of the drainage pattern with the laboratory. Now you have thousands of such matching, and then you have to optimize from these thousands of matching. So which one is correct, or which one is optimized for the other with other parameter. So maybe in November, because September, October we do have another workshops, or maybe in November we will have another workshop where we'll see the optimization of the byproducts data from HYDRUS and the mod flow. Yeah, we will try to explore more and more. So with this word, I'm going to stop here. If you have any question, please ask me, or we will say bye to this workshop.
Sir, just as a general comment, if there is a SLAG application, we can update from that application.
Yes, see, we have a Google group with SYAHI. I would like to request you. I will circulate the link to join. If you join us with this Google group, you will get every notice automatically. So not only related to this HYDRUS workshop, we have podcast series, we have 2-3 proposal writing workshop and SWOT workshop, 2-3 workshops are in line. So I would like to request you to join the Google group. And most importantly, our website, if you let me share again this screen and see our website, quality of our website, so good. Oh, sorry. If you regularly visit our website, you will get a lot of things like this in resource tab. Every day the new opportunities like postdocs, PhD opportunities. So every day we do have, recently we have listed 2 or 3 or 4 postdocs. We do have reviewer dictionary here, directory here to select the reviewer. And if you are interested to write a blog with us, you are welcome to do write a blog for a future event. Many members are interested to write participate or conduct future events. So you are also welcome to conduct such a future experiments. And for collaboration, see our research tab, we are updating the manuscripts. So every time, so every day, if there is a new manuscript from our member, we are highlighting or we are listing here, so that you can get direct link or direct citation of the research from our members. Membership is free. One can enjoy the membership, free membership. And in event tab, we do have advertisement of all these workshop and podcast. And here we are providing the link and source link, everything with the past events. If, for example, you can see here in our SYAHI Python workshop, we do have listed everything, the topic, session, lecture material, YouTube link, everything is listed here. And happy to announce that everything is free, nothing to pay. So feel free to explore with our website. So I'm the SYAHI team will happy to help you. And if you need like a personal or direct questions, so then you have to use like text us using the email or so on. Dr. M.K. Kaushik, sir, yeah. So I'm going to send you the detail, SYAHI detail. Okay. So I would like to conclude this session with this feedback remark from Dr. M.K. Kaushik, sir. So sir, please unmute your phone and please provide us your feedback so that that will help us a lot. Kaushik, sir, are you here?
Yes, sir. I'm audible?
Yes, yes. With your word, we would like to conclude this session. Yeah, thank you.
Whatever you have explained, it was really very nice and need of the hour. I worked in IIT Delhi with Professor Arun Kumar. So I worked on nano materials, especially some pollutants which come into the category and the modeling. So whatever was discussed there and whatever I have learned, I can call everything back in my mind, in my memory. It make me refresh now after attending this session. So it was a great experience. Thanks a lot, sir. This is first interaction with you, but I hope I will also definitely join the group and I will also share my experiences as well as whatever will be at my end, whatever will be available at my end, I will share with all the group members.
Yeah.
Thanks a lot, sir.
Thank you very much, sir. We are happy to have you, and yeah, please join our membership. And see, we are early career researchers, so we have to be helping hand to each other. And yesterday, if you watch the recording of yesterday, Professor Jirka already mentioned a lot about the nanoparticle and virus attachment, detachment theories. So HYDRUS is also capable to simulate such problem in subsurface environment. So with this word, I would like to thank you everyone, and please allow me to stop this session and have a good night. Take care. We'll meet again very, very soon, and please be in touch with the SYAHI member. Thank you very much.